During the last 100 years, earthquakes in Turkey have killed more than 60,000 people and destroyed dozens of towns. Hagia Sophia lies just 13 miles from one of the most active fault lines on Earth.
Turkey is located on what we call the Alpine Himalayan earthquake zone. This is the earthquake zone that's associated with young mountains and the mountain build-ups. And almost all earthquakes that takes place in this zone do take place under cities that are associated with great damage and the loss of life.
The last big quake struck Istanbul in August 1999. It measured approximately 7.5 on the Richter scale, about the same magnitude as the 1906 earthquake, which destroyed San Francisco. Seismic experts warn that the August 1999 quake may spark another major quake that will directly strike Istanbul.
The largest fault that's passing through Turkey is what we call the North Anatolian Fault, and it is an exact replica of the San Andreas Fault in California, and the earthquake hazards in Turkey and California are highly comparable to each other.
With a seismic record of destruction that extends back 4,000 years, and with countless buildings toppled all around it, why has Hagia Sophia not fallen? Dr. Çakmak believes Anthemius built Hagia Sophia to withstand earthquakes. Ancient records reveal that Anthemius studied seismic activity. At the time, builders believed the best protection from earthquakes was to build thick, heavy walls. But Anthemius realized these solid, rigid buildings were shaken apart by earthquakes. So he took a risk 1,500 years ahead of his time, deliberately trying a daring new building method.
What is unique about this building is that the architects, Anthemius and Isidorus, were aware of the damage that earthquakes could cause. And they tried to build a building that would resist earthquakes. The way they accomplished this was to make the building light and flexible, which is a very modern concept. Buildings in those days, to be made stronger, were made heavier and more massive.
Anthemius made Hagia Sophia light and flexible, not just with his design, but also by creating special building materials. He put a secret ingredient in the recipe for the mortar of Hagia Sophia: crushed brick.
The architect Anthemius crushes the brick into a powder, which he then mixes with lime, water, and sand to make a special mortar. This mortar is very strong in tensile strength.
The crushed brick makes the ancient mortar more tensile or flexible, in the same way that steel makes modern concrete more resilient. When Dr. Çakmak tested samples of the mortar, he found it still chemically active. That makes the mortar as strong now as it was the day it was mixed. Amazingly, the mortar has not deteriorated in 1,500 years. Not only were the building materials strong, they were also light. The bricks used in the dome were fired at lower temperatures, making them less dense and therefore lighter than regular bricks. That results in less weight bearing down on the supporting arches. Remarkably, the reduced weight also offers protection against earthquakes. By using lighter building materials, Anthemius was instinctively applying the physics formula: force equals mass times acceleration.
1,000 years before Newton, Anthemius had an intuitive idea of the concept of force equals mass times acceleration. Although he could not control the accelerations that would come as a result of an earthquake, he could reduce the mass by reducing the weight of the building, thus reducing the impact the earthquake would have on the structure.
Because these quakes can come in series, another may strike Istanbul soon. Can Hagia Sophia remain standing? In 1992, Dr. Çakmak started searching for the structural secrets of Hagia Sophia's earthquake resistance. He began by placing sensors around the building at points he suspected would suffer the greatest stresses.
Then we had to wait for an earthquake to happen, which happened in the April of 1992. The data from this earthquake allowed us to calibrate the computer model so that it was ready to predict the behavior of Hagia Sophia under future earthquakes.
The seismic activity generated by the small earthquake produced enough data for the computer model to identify potential trouble spots. During an earthquake, the areas that flash red, particularly the tops of the 4 huge arches, would be subjected to tremendous pressures. These points would be the most likely places for a disastrous collapse to begin.
And what we can now do is to hit this model with a 7.5 magnitude earthquake and determine what kind of damage it will sustain, if any.
With a click of his computer mouse, Çakmak unleashes an earthquake equivalent in strength to the biggest quake ever to hit Istanbul. The walls of the virtual Hagia Sophia begin to tremble. The great structure is shaking. Its walls and the dome are swaying as they are struck by the violent seismic waves. The colors yellow, brown, and red pinpoint the areas under greatest strain. As the killer quake ends, the walls of the virtual Hagia Sophia are still standing. Amazingly, the dome resting on top is unharmed.
Our observations are that although certain sections of the building are stressed, none of the stresses exceed the allowable limits, and our prediction is that Hagia Sophia will survive a 7.5 magnitude earthquake.
Dr. Çakmak's prediction made in June 1999 proved to be deadly accurate. 2 months later, a magnitude 7.5 earthquake toppled buildings in Istanbul. Amazingly, Hagia Sophia remains standing, a testament to the genius of its architects.
Throughout centuries, various external modifications have been made to the building. But the original design of Anthemius and Isidore's is still the most earthquake-worthy one.
Dr. Çakmak and his high-tech computer model were proven right. Hagia Sophia withstood the greatest quake in Istanbul's history. Hagia Sophia, born of the 6th century, will continue to keep watch over Istanbul through the 21st century, as if suspended from heaven on a golden chain.